Hi everyone, this is Young Choi. This recording is for NMC MG303 Business Statistics final exam prep for Chapter 7. And I'd like to highlight some of the questions in Chapter 7, especially for the documentation that I passed out. That is the test bank, so to speak. And I'd like to highlight the questions 39, 41, 42, 47, 57, and 62 in multiple choice questions category. And the problems area, question numbers 7, 8, 20, and 21. And when you take a look at the test bank that I gave, and one of the questions 39, in computing the standard error of the mean, the finite population correction factor is not used when the answer is C. And why don't you read page number 311 to 312. Actually, in the bottom of the page 311, the finite population correction factor, which is in this case, you may take a look at here, likely the finite population factor in this case, equation 7.2, when you calculate the standard error or standard deviation, that is root, in this case, population number, actually n, so this one is small n, and then divide by population, the size, minus 1. And here the standard deviation divided by actually sample size. So this portion is called finite population correction factor, and once it's likely less than 0.05, which means in this case the n over actually divided by the population, this size is less than or equal 0.05, then you may ignore. So why don't you read your textbook page 311 to 12, and then you can get the answer. In this case, C. Next question, 41. From a population of 200 elements, the standard deviation is known to be 14, and a sample of 49 element is selected, and then it's determined the sample mean is 56. Then what is the standard error of the mean? That is, let's put it here, likely the standard error deviation on next bar, that is 14 divided by root, in this case 49, and root 49 is a 7 basically, so it turns out 2. Then the finite population correction factor, in this case root 200 minus, in this case 49 elements and divide by 200 minus 1, so that will be basically less than actually, you know what, not equal, so less than obviously 1. So the finite population correction factor is less than 1, and then we multiply by together, then the answer is D, which is less than 200 right there. Next question, 42. From a population of 500 elements and sample of 225 elements is selected, and it's known the variation of the population is 900. Okay, 900, and then what is the mean of the standard error in that case? It's the same kind of a deal. Here you can take a look at, in this case, let's highlight it right here. This one will be 500, and this one will be 225, and then this one obviously 500. It's not quite working. So, and then we can put it in here. Let's just scratch it, and then multiply by, this is the finite population correction factor, and then you can put it in the standard deviation 30 and divide by, in this case, root 225 elements, which is the 15 power 2, so that turns out likely 2, and this one turns out in my calculation 0.742363. So approximately this one comes up with 1.4847, which is close to D as an answer. And then another question here, 47, and a random sample size 49 are taken from population that has 200 elements. It's the same kind of a deal, so you can make it, the answer will be C, 180 and 1.74. So same kind of calculation guideline will be applied to this question. And then 57. 57 is a population has a mean of 80 and a standard deviation 7, and a sample 49 observations will be taken. The probability that a mean from the sample will be larger than 82, that is explaining here. Likely the z-score, we can calculate it. Actually the mu is 80, and the standard deviation is in this case 7. Okay, then the z-score can be calculated. We are concerning on 82. Okay, and then the population has mean an 80, and the factor in this case here is the standard deviation 7 divided by 49 observation, which is in this case 1. So this one is a 1, so it comes up with the 2. Then you can take a look at the table. It's not quite normal curve, but it should be. And then we are talking about right there we have mu 80, and then we are concerning on 82 right there, and then basically we calculate this area. Actually this score 2 as z score, as you see right there. And then you can take a look at the table value. That is actually table 1, 0.9772. So you can subtract likely 1 minus 0.9772. That is equal to somewhere 0.0228. The answer is 57 D. Okay. The next one, you might take a look at question number 62. That's the random sample size, 525 taken from a process whose population proportion is 0.3. Okay, and 0.3, the standard deviation of the sample properties. If I were you, in this case, we better not use the finite population correction factor, and so in this case you might take a look at likely the root 0.3 and multiply by 0.7. Actually this one came from likely probability and then complementary probability, in this case 1 minus p, and something like that. And then I want to erase this guy a little bit, something like that. Anyway, and then divide by 525. So it comes up with somewhere 0.02. So the answer is D as in dog. Okay, that is the one, the problems that I have as highlighted. So I'm continuing to discuss on problem side in next slide.